Hi, this is Dr. Grillo. And before you do this lab, again, you're encouraged to watch the video where I explain the differences between a stateless and stateful firewall and go over security zones on the ASA firewall. In this lab, we have an internal network, which is our most trusted network, and we want to allow access to the web server. After we advertise routes with the IGRP and the ASA advertises the TMZ to us, and we advertise our internal network to the ASA from the branch router, we should be able to reach the web server. Now, the problem is replies can't come back because it's coming from a lower security zone. So we'll need to set up access control lists on the ASA firewall. We'll also create a loopback out on the ISP to represent a fictitious public address out there somewhere, and from the ASA we'll create a default route to the ISP. Okay, and so we'll go ahead and get started. First thing we'll do, we'll click on the branch router, and the instructions for setting up the branch router are right here. Type NO for no, enable, config T, and first thing we'll do is we will switch to the gigabit 00 interface. Now I'm going to put the instructions right here so you can see them. Click back on the branch router. Now we have a gigabit 00 interface on the branch, which has a 192.168.100 network. We're going to give it an address of .2. The firewall will have an address of .1. Okay. And so let's go ahead and get started. Okay, we'll switch that interface. We'll type INTG00. We'll set the IP address of 192.168.100. It should be a .2 address, I believe. Yes, this should be a .2, not a .1. Because .2 is the IP address right here. The ASA is going to have an address of .1. So I fix that. So we type in the command 100.2, hit the space bar, 255, 255, 255, 252. We do the no shut command. And then we'll switch to our second gigabit interface, which is our gateway for the internal network, and hit enter. Type the IP address of 10.0.0.1, 255, 255, 255.252, and we'll turn on the interface with the no shut command. Okay. We'll set up our EIGRP routing protocol to advertise our networks. We'll type router EIGRP 100. That's the autonomous system number. They have to match on both ends. We'll advertise our network by the Class A, Class B, Class C default address. So we got two of them connected to us. And we want full advertisement of the network address and the network mask, so we have to use the no auto summary command. And we talked about that in the last lab. And that completes the configuration of the branch router. Okay. Now, I already did the IP address of the PC. So if you click on the desktop tab, go to the IP configuration window, make sure you have the following IP addresses, okay, on the PC and the web server. And they're right here. So go ahead and key that in. You can hit the pause button while you're typing that in. Close the window. And likewise, you want to do the same on the web server. 172.16.02, network mask, default gateway. Okay, so those are already done, and the branch router is configured. Our next step is to do the interfaces for the ASA firewall. So I'm going to put this back here. going to get it out of the way. We really don't need it. And we're going to open up our ASA Firewall window. And I got the instructions here on how to configure the ASA Firewall. What we're going to do is we're going to create IP addresses on the interface. We're going to assign a IP and a network mask. We're also going to name our interfaces. And you'll learn that configuration of the ASA Firewall is a little bit different. For example, if you type enable, you're prompted for a password. Well, there is no password by default on a ASA Firewall, so you just hit enter. If you wanted to configure one, you'd go config T, and you would type enable password space followed by whatever the password you wanted it to be. I'm going to skip it, and we're going to go to our interface, gigabit 1-1 interface, and we're going to give it a name. Type name IF space DMZ. We'll do the DMZ first. It's in all caps, and we'll specify. Now notice the security level, they set it to 0 by default, okay? We want to change that security level to 50. So you type security-level space 50, and you key in the IP address of 172.16.0.1, 255.255.255.252, and then your no shutdown command. Okay, next step is to configure the 1-2 interface, which is the outside, the public, right? So you go to that interface, G1-2. The name we're going to give it, outside in all caps. Hit enter. Now, outside set to 0 by default. We want to leave that as is. You could type in the security level if you want. Security level 0, right? Because it's the least trusted network. Anything coming from the outside should have a security level of 0. We're going to type IP space ADD 1.1.1.2, 255.255.255.252, no shutdown command. Okay, now it's down because we need to configure the other end first, and then we'll hit enter. And from here, we will type the interface address for gigabit 1/3. So we type G int space G1/3, give it a name, and we'll call it inside. Okay, we want to set the security level to 100, most trusted, followed by the IP address, 192.168.100.1, 255.255.252, and we'll type the no shutdown command. Okay. Now that completes the addresses of the naming of the interfaces on the firewall. So you have 3 interfaces, right? 1.3, which is our inside zone, which is the most trusted because our internal network right here. You have the DMZ, which is slightly trusted, right? Because it belongs to us. Still, you're allowing, in theory, you're allowing public access to your web server. So it's trusted, but it's not quite as trusted as your inside zone. And then you have this outside zone, which has a security level of 0, which is our least trusted. Okay. Now we're going to set a default route, right, to the ISP, because in theory, this is the edge of our network, and here's our internet service provider. You wouldn't want all the ISP routes being advertised to you, right? That would flood your routing tables. What you simply want to say is anything not in my routing table, send it to the internet service provider, okay? And it's the internet service provider's job to route traffic to and from public addresses out there, okay? So how do you create a default route? Well, notice the instructions here, right? If you recall on a firewall, the command was IP route, right? On firewalls, everything has names mapped to the interfaces. So we use the term route outside, which means this is our outside interface right here, gigabit 1.2 going towards the ISP. and you use the quad 0 to represent any IP address, any network mask not in my routing table, send it to 1.1.1.1.1, which is the internet service provider. I got an extra 1 in here, so let's fix that. There. That looks better. Okay. So again, we go to the ASA, we type exit, global config mode, and instead of IP route, we type route and hit the question mark. 3 choices, right? These are the names of our interfaces. We want to specify outside, space, all caps, quad 0, space, quad 0, space, 1.1.1, which is the next hop IP to the internet service provider. And hit press enter. Okay. We want to set up the router EIGRP, all right, like we set up on the branch router and advertise our network to the branch router. So we type router EIGRP, autonomous system number has to match, specify the network that belongs to you by your class A, B, or C address. And then use the no auto summary and press enter. Okay. Okay. We're going to do the access list last. Okay. Well, right now, if you look on the branch router, for example, if we type the command do show IP route, you'll see that ASA Firewall is advertising the DMZ network address to us. So the branch router knows that this exists and it knows to send traffic to the ASA. And if you look at the ASA Firewall, and all you have to do here is like not show IP route, but if you type show route, commands are a little bit different on the firewall. You'll see that the ASA Firewall can see the internal network. And you can also see who it's advertised from, right? 192.168.100.2 is advertising the network, which is this IP address right here on the branch router. And likewise, if you go on the branch, you could see who's advertising 172.16.0.0 network, which is the IP address on the ASA Firewall. Now, if I were to ping the web server, right, echo requests can go through because you got traffic going from a higher zone into a lower zone, which is permitted. The problem is that the echo replies can't come back to the PC because then you have traffic coming from a lower zone trying to get into a higher zone. And I can demonstrate that if I click on the PC, click on the command prompt, and if you try to ping 172.16.0.2, the echo replies aren't coming back to us. Now remember, if you get a destination host unreachable message, that means the branch router is dropping the packets because it doesn't know how to reach the 172.16 network. That's where the EIGRP comes into play and router network advertisements, okay? And that's why it's important to check the routing tables before you try to do the echo request, echo reply, okay? The traffic is going through, it just can't come back. So we're going to create an access list eventually that's going to allow the web server to send echo replies back into a higher zone and back to the PC here. Okay, so we'll skip the access list for now, and we'll configure the internet service provider. And we're going to create a loopback interface on the ISP to represent a network out there on the internet that we would theoretically want to reach. Okay, so we click on the ISP router, and for no, press enter, enable, config T, and type intg0/0, type IP ADD 1.1.1.1.1, 255.255.255.252, and then we use the no shut command to turn it on and configure the serial 00 interface, which is our connection to the internet cloud. Hit enter, and type IP ADD 2.2.2.2, 255.255.255.252, no shut. And finally, we're going to create our loopback interface. Comes up automatically and give it an IP address of 3.3.3.1, 255.255.255.252. You can do the no shutdown command if you want, but it's already on. Okay, that completes the ISP configuration. Okay, so what we want to allow, let's work on this access list for the DMZ first. Okay, we're going to allow the ICMP echo replies to come back to the PC. Okay, and so we go to the ASA Firewall, and I'll scroll down on these instructions so you can see the access list. Okay, we type exit to get back to global config mode. Now the access lists are done differently, right? If you recall, on a Cisco router, not a firewall, we specify a number, right? 1 is a standard access list. 1 through any number between 1 through 99 is a standard access list that's based on the source address only, and numbers 100 through 199 are extended access lists, which are based on the source and destination and the protocol, if you wish. Okay, but it's done differently on an ASA. In this case, we specify a name for the access list, the DMZ, to map it to that DMZ interface, and hit the space bar, and we specify extended space. And you type permit. Everything else is the same. You type permit space. We're going to type ICMP, which is being as part of the ICMP protocol. We're going to specify the host address, which is the source, 172.16.0.2, right? And the destination will be the host, will be the PC 10.0.0.2, and we're going to allow echo replies to come back to us. Okay? Now, you could do this if you want. If you want to type in any IP, so if you want it, you could type another access list, type extended, permit, and instead of ICMP, TCP, UDP, when you type IP, that's everything. And you could type host 172.16.0.2, that's the source, destination host 10.0.0.2. You don't have to specify a protocol because you're allowing everything. Okay. Next thing we want to do is specify an outside list, right? So we want to be able to reach that fictitious loopback interface at 3.3.1, because again, we can reach it because we have a default route to the ISP. Problem is the echo replies can't come back to us, okay? For the same reason, it's coming from a zone 0, right? Trying to get back into a zone that's higher, okay? So to do that, we type access dash list outside in all caps, extended, permit, ICMP, host. The source is going to be 3.3.3.1. The destination will be, we'll just use the interface on the ASA firewall because we don't have network address translation set up, but theoretically that would be the host address because all the addresses would be translated out on that interface like we did last lap. Okay, we're going to allow echo replies and hit enter. And I'm also going to allow echo requests because I want to show you how to do an extended ping on a router where a router has many IP addresses associated with it on its interfaces, but how you can specify a specific IP. Okay, so that's the only purpose of doing this next access list. We type access dash list outside extended permit ICMP host 3.3.3.1 host 1.1.1.2, and we're going to type echo, which is echo requests. Okay, now how do you apply the access list to an interface? Well, on a Cisco router, as you recall, you do access group followed by the number, okay? Well, it's a little bit different. And then you'd go to that interface, you would apply it on that specific interface. Well, you apply on a ASA firewall, you apply access lists in global config mode because you specify the interface. So to do that, you type access -group. We'll do the DMZ first. This is the DMZ. These are the two access lists we created for the DMZ. Okay, we want inbound, and then you specify the interface in global config mode. So if you hit the question mark, those are your three options. You would type DMZ. Okay, then hit enter, right? Then you type access -group outside in all caps, inbound interface, and then you specify outside. So that applies those two series of access lists to those two interfaces. Again, it's done differently on an ASA. Okay. So really our last step is to kind of test it because we've done our configuration. And the first thing we want to do is see if we can reach the web server now from the PC. So we click on the PC again. Now remember, we couldn't ping it before. We should be able to ping it now because the echo reply should come back to us. And then you get a successful reply. Okay. Now, likewise, you can go on that web server. I think I might have already done this. You go to services, click on HTTP. Under index.html, again, click on edit, and you could change the title of the website to anything. I put welcome to Capella University. You could type anything in there. Just make sure you save it at the end. Save it. It's not going to hurt to save it again. And now we want to go to our browser because we're allowing all traffic to come back into the zone right here. We click on the PC and we go to the web browser. I'll get it to work. There it goes. And we type http://172.16.0.2, and you'll see welcome to Capella University. Okay. Now there's a couple things we could have done how we could have done the access list. Okay. If I did a specific IP, since there was only one IP on this network, okay, under this access list, where I'm specifying a destination, I could have done the entire network address. So I could have done it. In other words, I could have typed it like this. Access -list DMZ extended permit ICMP host. Now you only have one host, it's the web server, so that's still valid. Now if I want to, let's just say I had more than one PC, I had several on them on this network segment, right? But there's only two available IPs. Let's just say instead of a 252, I had a 255.255.240 for that internal network for the 10.0.0.0. So 240, if we recall from the subnetting lab, it allows 14 available IPs. I could have done, instead of typing host, which is an individual IP, I could have just typed in the network address, okay, followed by the wildcard mask. And the wildcard mask is the exact opposite of the network mask. So instead of 255.240, I type 0.0.0.15. That would have had the same effect, and it would allow access all PCs on this segment, okay, and not just .2. So when you're doing your access lists, you can specify an entire subnet versus an individual host. Okay. So we've got, you got to see how the firewall works, right? How initially traffic from a lower zone can't go into a higher zone. But once you set your access list to allow traffic from a lower zone into a higher zone, you see how the echo reply and how we can view the website. Okay. Now, likewise, right? we want to be able to go on our ASA firewall and ping that 3.3.3.1 address. It represents a public address out there on the internet. So if you go on the ASA, let me hit escape, and you type exit, and to get back to privileged exec mode, type ping 3.3.3.1, and you'll see it's successful, right? Hit it again, you'll get 100%. Okay, so initially, without that access list, we can send echo requests to the loopback, no problem, because we have a default route to the ISP. That 3 network's not in our routing table, but we know who to send it to, the ISP, right? And it's going from a higher zone to a lower zone. That's okay. Problem is that echo reply can't come back without the access list, because it would go from a lower zone into a higher zone. Okay. So one last thing on the ASA firewall is save our configurations, right? It's a little bit different. Remember you did a copy run start? Well, copy run start doesn't work if you try copy run start. Okay, so it did work. Okay, now if you type show start, you can verify what we did, right? We configured interfaces with names, set the security level, set the IP addresses for all of them. Okay, if you hit the space bar, you can see we created a default route on our outside interface for any IP address not in our routing table, and we send it to the IP address on the ISP. Okay, and then we did our access lists, and then we applied our access lists. Okay, so you hit Q. Another way to save the file, instead of copy run start, you can do what's called write mem. It means the same thing. This accomplishes the same thing. Now, I gave it a host name of ASA Firewall. Again, if you wanted to create an enable password, you type enable password Cisco. Okay, and you can do those things. And now you can go on the branch router, enable config P, give it a host name, branch router, put a dash between words if you want. Okay, and to save it, type end, and you could do a copy run start or write mem. Accomplishes the same thing. Okay, and likewise, you want to do the same for your ISP. Enable config T, host name, ISP, end, copy, run, start. Okay. Well, that completes the lab, and please reach out to me if you have any questions. Thank you.